Hey, 20-1s. Here we are in the next lesson of sequences and series. And this one's about the applications of arithmetic sequences. And it's not going to be a big leap from where we were after the first lesson. We're just going to, first off, do a quick review of what we did last time. And then we'll go into what this will look like graphically, and then maybe an application question. So consider the arithmetic sequence given by Tn is equal to 3n plus 8. And it says, find each indicated term. Okay, so T1, all I'm going to do is I'm going to let n equal 1. No big deal, right? So T1 is equal to 3 times 1 plus 8. T1 then is 11. So there's your first term. T7, well, same idea. You're simply just going to let T equal 7. So T7 is 3 times 7 plus 8. Well, that's 21 plus 8. That sounds like 29 to me. And T14, sure, guess what? We can do the same thing here. So T14, we let T equal 14. And so what do we get? Not let T equal 14, let n equal 14. T14 is 3 times 14 plus 8. And so T14 sounds like 42 plus 8 is 50. Okay, so I mean, there's what we were kind of playing around a little bit with last time. But the question is what does this sequence look like graphically? Okay, well, if you notice here that that almost looks very similar to this one that you did in 10C, or if your teacher wrote it as AX plus B. Do you notice that? That was called your slope-intercept form from grade 10. So do you notice this looks almost the same, just that now it's Tn is equal to 3n plus 8. Well, let's try to use our skills from grade 10 to graph this thing. So let's draw ourselves a grid. And I'm only going to focus in quadrant 1. Why would I only focus in quadrant 1? Well, because the x-axis is now actually the n-axis. It's the number of terms, right? And we can't have a negative number of terms. The y-axis is now going to be the t sub n axis because it's the value of each term. So now if we go to graph this, what I'm going to do is I'm going to start to build down here. 1, 2, 3, 4, 5, 6, 7. Okay. And then up the Tn axis here, I'm going to maybe make a little bit of a scale. So I'm going to go 5, 10, 15, 20. Well, if we're looking at this thing, term 1, what we found above here, when it says when n is 1, the value is 11. And then the next one we figured out is when n is 7, the value is 29. So that's going to be somewhere up there. And T14, well, I should have extended my axis a little bit further, shouldn't have I? Let's say it's somewhere out here. There's 14. Well, T14 is at 50. It's going to be way up here. Now, so I plotted my points. No big deal, right? In grade 10, when we were dealing with slope-intercept form, we would always connect the points because it was a continuous function. X could be any value in most cases, but here we won't. We won't connect these points. Why not? Well, if we connected the points like this, and we said, here's our line, what that just said was anywhere in between here. So say right here at 1.5, n is 1.5, or n is 2.5, or n is 3.6. What you're saying is there's such a thing as the 3.6 term or the 2.9 term. It doesn't make sense. So this isn't a continuous graph. What this is a series of points like this. This is called a discrete graph. The This is discrete data. So we don't connect the points. We also, I know you know from grade 10 that that's the y-intercept, which would be right about here. But I can't put that point there because that would be term 0. There's no such thing as term 0. I have to start with the first term. So even though we can still use our skills from 10C to have an idea of what this graph is going to look like, we have to change our thinking a bit. Okay, so there's what these graphs look like. A sequence graph like this is going to be discrete data. It will not be continuous. Now, one more question we want to look at here. Here's an actual application question. So Susan joined a class at her local gym, and in her workout, they put in a sit-up routine. So it's an arithmetic sequence. On the 6th day, she did 11 sit-ups. And on the 15th day, she did 29 sit-ups. Oh, she's getting a lot better. Okay, write a general term that relates to the number of sit-ups to the number of days. Okay, so coach has some sort of pattern here, and we're going to figure the pattern out. So it says T6, she did 11. And on the 15th day, T15, she did 29. Okay, well, remember our formula from last lesson. T1 plus n minus 1 times t. So whenever I'm stuck and teacher gave me a formula, what I learned over my many years of doing math is I'm just going to start subbing things into my formula and see what happens. And simplify. Okay, one equation, two unknowns. No can solve. So good thing they gave me two data points here to work with, because then we can make two equations, two unknowns that we can solve. And remember what we did last time, friends. From here, we made a system from these two. So we're going to make a system here. And again, it doesn't really matter the order in which you do this. And I'm going to do elimination, I should say that. Some of you might prefer substitution, but I think elimination's easiest because I'm going to subtract and the T1s will cancel. We'll get 0. And 14D minus 5D is 9D. And so D is 2. There's my difference. Okay, well, that's good. We've got the difference, but we still need that first term, don't we, friends? So now to find T1, what's T1 equal to? Well, let's let D equal 2. And let's sub it into either one of our terms, general terms that we've started to build above. I'm just going to choose that one. It's got slightly smaller numbers. So I sub it in. Term 1 plus 5 times 2. Well, I can see right there that's going to be 1. On her first class, coach was taking it easy and said, let's just do 1 sit-up. Cool, I dig it. So what's our general term then? Tn is equal to 1 plus n minus 1. And on each successive day, we're going to do 2 more sit-ups. Awesome. There it is. There is our general term. Now that we figured that out, we can now figure out B. If Susan's goal was to be able to do 100 sit-ups, not a chance I can do 100 sit-ups in one sitting. What day will she accomplish this on? Okay, so let's see. Let's switch to pretty purple. Well, she wants to do 100 sit-ups. What day? So really what we want to do, what day? Well, really what we're looking for here is we're looking for what's n, right? So let's use our general term. She wants to do 100. We need to know on what day. That's n. Okay, I'm going to subtract 1. Like that. I'm going to divide by 2. Okay, divided by 2. What are we going to get there? We're going to get 49.5 is equal to n minus 1. And then add n over, or 1 over, I should say, and we're going to get 50.5. Okay, so it's going to take her 50.5 days. Well, yes and no. Like, we're talking about what day. A day is, again, it's day 1, day 2, day 3, day 40, day 41. There's no such thing as point 0.5. So what day is it going to be? Are we going to round this up or are we going to round this down? Well, I'm not even using the rules of rounding here. I'm just thinking about that point 0.5. If I rounded down to 50, would she have done 100 sit-ups? No, she would be under. She wouldn't meet her goal. If I round it up to 51, will she have met her goal? Yes, she will have met her goal. So I didn't really use the rules of rounding there. I used logic to think about which way I should round this thing up. That's an important little step. We're going to have to do that in 30-1 as well. So looks like it's going to be on day 51 for her. How do I check my work? Because I always like to check my work, right? Well, to check my work, let's go to pretty black. Well, let's just think about, we've got our general term. What would happen if we let n equal 51? Let's sub in n is 51. So to check our work, let's sub it in. 1 plus, and our general term was n minus 1 times 2. So we'll sub that back in. 51 minus 1 times 2. And we just want to make sure that she's met her goal, don't we? Well, that's 50 times 2 plus 1. Guess what? She did 101 sit-ups. So on day 51, she meets her goal. There it is. There's an application question. You'll see some of those in your homework. See you next time, my friends.